All right, real quick. It says which equations have no real solution but have two complex solutions? Well, basically what we do is we want to make our equations look like this: ax squared plus bx plus c equals 0. Then we're going to find the discriminant based on the a, b, and c values. If that discriminant is negative, then it has complex solutions. And that's what they're asking for. So our first one, 3x squared minus 5 equals negative 8. I just jot down here. Then to solve, or not solve, but make it equal to 0, I'm going to add 8 to both sides, and I get 3x squared minus 5x plus 8 equals 0. That tells me that a equals 3, b equals negative 5, c equals 8. Then I plug that into my discriminant formula, which is b squared minus 4ac. That's going to be negative 5 squared minus 4 times 3 times 8. So that ends up being 25 minus 96 is equal to negative 71. Because this is negative, it is a complex solution. So we just put a box around it. This one is complex. All right, so when you go to do this online, you're going to click on the ones and highlight the ones that are complex. So you would click on this one. For this equation here, we're going to do the same thing. I'm going to add 5 and subtract 6x from both sides of the equation. That helps me to solve for 0. So I've got ax squared plus bx plus c. In other words, a is equal to 2, b is equal to negative 6, c is equal to 5. Fill in negative 6 for b, 2 for a, 5 for c. You get negative 6 squared minus 4 times 2 times 5. Do that on the calculator. You get negative 4. Because the discriminant is equal to a negative value, that is a complex solution. For the third one, I've got 12x squared, or 12x equals 9x squared plus 4. Again, we solve for 0 by doing the opposite. That tells me that a equals negative 9, b equals positive 12, c equals 4. Plug that into the discriminant formula. 12 squared minus 4 times negative 9 times negative 4. This actually cancels out to 0. It's 144 minus 144, which is 0. That's a real solution. Whenever the discriminant is not negative, you end up with a real number solution. What that means is if I plug this into the quadratic formula, I would get x equals some sort of number. Remember that the discriminant, you were in the quadratic formula, we're taking the square root of the discriminant. You end up with a complex solution because you would have to take the square root of a negative number. You can't do that with real numbers. You got to use complex, the imaginary number I. We did a little of that last year in geometry, but not a whole lot. Lastly, negative x squared minus 10 equals 34. Again, I'm going to add 34 to both sides. No, I'm sorry. Starts off as positive 34, so I subtract 34 from both sides. So that means a equals negative 9, b equals negative 10, c equals negative 34. Plug that into my discriminant formula. I get the discriminant is equal to a negative value. Therefore, it is a complex solution. So 3 out of the 4 are complex. Are there any questions on that one?